This problem says the rate at which people enter an auditorium for a rock concert is modeled by the function r, given by r of t equals 1,380 t squared minus 675 t cubed. It says t is in between 0 and 2 inclusive. R of t is measured in people per hour. No one is in the auditorium when t is 0, when the door is open. The doors close and the concert begins when t equals 2. Part A says, how many people are in the auditorium when the concert begins? Since r represents the rate at which people enter the auditorium, and r is measured in people per hour, when we integrate r from 0 to 2, that's going to give us the total number of people who entered the auditorium by the time that the concert began. On the calculator, we're going to press y equals. We're going to type in the function for r as our y1. So now we have r of t as our y1. Let's go ahead and press math 9. And we're integrating from 0 to 2. We want to call up r of t as our function. So I'm going to press alpha and then trace. There's our y1, and you get 980. You have 980 people in the auditorium when the concert begins. Part B says find the time when the rate at which people enter the auditorium is a maximum, and then justify your answer. So because we're working with a maximum, we want to look at the derivative of r and set that equal to 0 to find our critical values. Since r is listed as our y1, in the y2 slot, I'm going to do r prime. So we're going to press math, and then we're going to use math 8. So we have ddx of y1, which is our r, and I just left this as x equals x. I'm going to unhighlight. I unhighlighted y1, so now we just have y2 is highlighted. I'm going to hit graph. You can see that r prime is hitting the x-axis at 0 and also right here in between 1 and 2. So we're going to find this 0. We're going to press second trace 0. So right now it wants the left bound, so we're going to arrow to the right. Finally, it's starting to come back down, so we're at 649. We're at 370. And finally it went negative. So we're going to arrow left one more time. That's going to be our left bound, press enter. Now arrow right, and now that we're negative, press enter. Enter one more time, and here's our x-intercept, 1.36296. So I just made a note, at t equals 1.36296, r prime of t changes from positive to negative, therefore r of t has a relative maximum at 1.36296. So we just identified that this value is going to be one of the candidates for when the rate at which people enter the auditorium is a maximum. So I set up a quick little chart here, and it's going to be t values. You have your endpoints, and then you have your critical value, your candidate for the relative maximum. And then over here you have r of t. So now we're going to plug in 0 and then the 1.36296 and also 2, the two endpoints, into the function for r to find out which one produces a maximum. Just a reminder, we have r of t as our y1, so we're just going to keep calling up y1 when we do this. So r of 0 or y1 of 0 is going to be 0. So now we're going to go r of the 1.36296, and you get 854.527. And when you plug in 2, you get 120. We're going to double check for part B. It wanted the time when the rate at which the people enter the auditorium is a maximum. So here you can see that this produced the biggest value, but we want the time, so the time would be the 1.36296. Because it's a final answer, I'm going to round to 3 decimals, so our maximum rate occurs when t is equal to 1.363. Part C. The total wait time for all the people in the auditorium is found by adding the time each person waits, starting at the time the person enters the auditorium and ending when the concert begins. The function w models the total wait time for all the people who enter the auditorium before time t. The derivative of w is given by, we have w prime of t equals the quantity 2 minus t times r of t. It says to find w of 2 minus w of 1, the total wait time for those who enter the auditorium after time t equals 1. So w of 2 minus w of 1 equals, and if you notice we're kind of going backwards, we're going to do the integral from 1 to 2 of w prime. So again, when you integrate w prime, you get just w, then you evaluate it by plugging in 2 minus plugging in 1. Which is this expression right here. We're given w prime, so let's go ahead and plug that in. So now we have the integral from 1 to 2 of the quantity 2 minus t, r of t dt, and we're going to use the calculator to find this. So we're going to go math 9, and then our integrand is 2 minus t, and we're timesing it by r, which is our y1, and you get 387.5. Part D says, on average, how long does a person wait in the auditorium for the concert to begin? Consider all people who enter the auditorium after the doors open and use the model for total wait time from part C. So I kind of wrote this out to give us like a game plan. I wrote total wait time for 0 to 2 hours, and then what we're going to do is divide by the total number of people in the auditorium when t equals 2. So we found the total number of people in the auditorium when t equals 2 from part A. We got 980, and then we're going to integrate from 0 to 2 of the w prime. So we're going to plug this right into the calculator. So I have 1 over 980. We're going to do math 9. We're going 0 to 2. You have your 2 minus x, and then call up our r, which is still y1, and we get 0.776. So on average, a person waits 0.776 of an hour. Thanks for watching, and if you don't mind, go ahead and hit the like button and subscribe to Math with Yosh. Thanks, guys.